working on the states of matter here. We've talked about gases. We talked about liquids. And the other one we're going to look in depth at. Now there is another state of matter, the plasma state. We don't talk about that too much at all in this class. That's a state that exists like in the sun. And probably we're not going to visit the sun anytime soon. At least you and I aren't. So we're going to stick with our basic three: gases, liquids, and now solids. With solids, the particles in solids are much more densely packed than in a gas, and quite a bit more densely packed than a liquid. So solids in general are denser than liquids. So usually a higher density, since those particles are packed closer together. And therefore, those interparticle reactions, those ones that we talked about with liquids, the dipole-dipole interactions, the London dispersion forces, and the hydrogen bonding, are much more effective because those particles, those atoms, are much closer together. So when the particles are closer together, those attraction forces are stronger, all right? Okay, there are two types of solids. Oh, looks like I've got some nice pictures here. If I remember what they are. I think I do, we'll see. Okay, the first type of solid is the cool kind, the crystalline kind, and that is made up of crystals. What is a crystal? Well, it's when you have the particles, the atoms, arranged in a very geometric pattern, an orderly geometric pattern, and repeating. So it keeps adding to that. So we've got some nice pictures here. There's lots of crystal structures, lots of possible crystal structures. Okay? And that is, a crystal structure is just basically what is the description of the three-dimensional arrangement of the particles. You'll find these descriptions on page 321. Okay, so we can have cubic crystals, which are cool, look like little boxes or cubes, such as this one. This is fluorite, and this is sodium chloride. And you guys have probably, I think we've looked even in class here, looked carefully at sodium chloride crystals with even just a magnifying glass. You'll have you do that? Nah, I don't know. We'll see. It's really cool. They're little cubes. And that's fluorite. Easy to understand. That's a shape that you're familiar with. Alrighty. Okay, another crystalline crystalline structure is a hexagonal crystalline structure. Hexagonal just means it's a prism that's based on a hexagon, which is a six-sided figure. Emerald is this kind of crystal when it's in its crystal form. And so here's, a bunch of hexagonal prisms. You can see these are the bases of these prisms are six-sided figures, 1, 2, 3, 4, 5, 6 hexagons, right? And so that's one of the other type of crystalline structures. Pretty cool looking. That's emerald. Alrighty. Trigonal is sort of 3D triangles, which are cool. Calcite, this is calcite here, and you can see the triangles here, sort of pyramid looking things. That's a trigonal crystalline structure, very pretty.